Hello, everyone. So, Miss Rhodes contacted me and asked me to go through Chapter 5, questions 6, 11, 14, 16, and 18 because there were a great many people who were having a difficult time understanding either what they were supposed to do or how to do it or what have you. So, I'm going to take a look at that right now. So, here's number 6. Number 6 says we need to simplify. So, what we're going to do to simplify this is we're going to try to find anything that's common between our numerator and our denominator. So this would be our numerator up here, and the denominator is down below. And what I'm going to do is I'm going to start by taking the numerator, and I'm just going to work with the 15. And I'm going to prime factorize it. So I know 2 doesn't go into it because it's odd. So it has to be 3 because this is divisible by 3, and the other answer is 5. So I know that 3 times 5 is 15. So I'm going to write that in my numerator, and I'm going to write y to the 5th power. Now 5 is just a prime number, so I don't have to worry about that. Just write that back in the denominator. And y to the 4th. Okay, so as you can see, there is a 5 in the numerator and a 5 in the denominator. This is kind of like saying 3 over 1 times 5 divided by 5 times y to the 5th power over y to the 4th power. 5 divided by 5 is 1. Okay? So this is going to leave us right now with 3y to the 5th over y to the 4th. Now let's take a look at the y's. So in the numerator, I have 1, 2, 3, 4, and 5 y's over 1, 2, 3, 4 y's that are multiplying. So y over y is a 1, and y over y is a 1, and y over y is a 1, and again, another 1. Just leaves us with a y in the numerator. So this is like saying which I can just rewrite as 3y. And that's the solution for 6. Let's look at 11. The lowest common multiple of 21x squared y and 7xy is, well, the lowest common multiple is the smallest number that either one of these numbers could divide into evenly. Okay? So, if I look at this, for 21, x squared y, I have 3 times 7 times x times y. And for 7xy, I have 7 times x times y. So I can see I have 7s, right? In both. And I have 1x in both. And I have 1y in both. So I'm going to go ahead and rewrite those. Those are common between both of them. Now what's not common between them is the 3 and the x. So I'm going to have to multiply those in too. When I simplify this, I would say I have a 3. Let me go back. I have 3 times 7 right here, which would be 21. I did the numbers. Next I have an x and an x. And when I have two things multiplying that are the same base, I can give them a power of 2 if there's 2 of them. And then y. So this is kind of a trick question, but the lowest common multiple here is 21x squared y. $14. I think there were some instructions with this one that said something like placing the dividing term underneath each one of the numbers in the numerator. So what that means is we could rewrite this as a fraction. And then I could rewrite this as that x squared, 6x squared, under each term. Under the 24x to the 6, the 18x to the 5th, and the negative 36x squared. You're probably saying, well, why can I do that? Well, kind of a little side note here. Let's say I had, I don't know, let's go with something simple. 3/4. Well, I could write 3/4 as 1/4. Actually, let's even make it simpler. 1 plus 2. That makes 3, right? Over 4. And then I split this up. I could say, well, this is like 1/4 plus 2 over 4. Which is like saying 1/4 plus 1/2. This is the opposite of finding a common denominator. Okay? So we're going to do the same thing over here. And we're going to say, well, plus 18x to the 5th over 6x squared, and then minus 36x squared over 6x squared. Well, how many times can 24 be divided by 6? That is 4. How many x's do I have? Well, I have 6 up here and 2 down here, so I have 6 minus 2 x's, 6 of them, minus 2 of them. So let's explain that. Over 2 of them, right? 1, 2. Means I have 4 of them remaining. So I can literally just say whatever the exponent is on the numerator, base, in this case it was x to the 6, and I can subtract the 2 from x to the 2 away from it and get 4. Now we move on to the next term. 18 divided by 6 is 3. Now if I have 5 x's multiplying, and I'm dividing by 2 x's down below, then I can say, well, there's only 3 x's left in the numerator. It's the same idea. It's x to the 5th minus 2 equals x to the 3rd. 36 divided by 6 is 6. These x's just cancel out. This would be, x to the 2 minus 2, which is x to the 0. Okay? So our final solution here would be 4x to the 4th plus 3x cubed minus 6. 16. Solve x over y squared divided by y cubed over x squared. All right. So I'm going to write this like this. I'm going to say x over y squared divided by x cubed over x squared. Now there's this really neat thing where we can say keep, change, flip. We're going to keep the first term the way it is. So this is going to be x over y squared. We are going to change division to multiplication. And we are going to flip or use an inverse like this to turn this fraction upside down. And this is a mathematical rule. I'm going to show it in a different way really quick too. This is x cubed, because I have not 1, but 3. 3x is multiplying. Same down here, right? I have y squared and y cubed, which means I have y to the 5th power. This keep, change, flip thing actually comes from somewhere. See, I could rewrite the division as what they call a complex fraction. And then I'm going to divide it by or multiply it by a form of 1 for my denominator, which is x squared over y cubed. And if I have that in the top or the bottom, I have to have the same thing in the top. And as you can see here, right, I get a cross cancellation. X squared and x squared is 1. Y cubed over y cubed is 1. All that's 1 down below. But everything in the numerators has to multiply. And the denominators has to multiply. So that's where keep, flip, change, or keep, change, flip comes from. 18. This one came with steps. So here's what I would do, right? First, I would find what is my greatest common factor, or greatest common multiple. So I have 10. That is 2 times 5. I have 5, which doesn't have 1. It's just 5. And I have 8, which is 2 and 4. But 4 is 2 and 2. So I know now that 10 equals 2 times 5. And 5 just equals 5. And 8 equals 2 times 2 times 2. Now I'm going to look at what's common here. What I have common-wise. Well, I have 5's common. So I'm only going to write those once. I have 2's common, so I'm only going to write those once. And then I have not 1, but 2. 2's left over. So I'm going to write each one of those once. So 2 times 5 times 2 times 2. That's the number we're going to work with. Okay, well, we know that 2 times 2 times 2 is 8, right? Because we're right here. So this is 8 times 5. 8 times 5 is 40. So what's neat here is that 10, 5, and 8 all divide into 40. So we need to look for values in our original problem here that make these things add up to be, these denominators be 40. So what makes this first 10 right here be 40? Oop, that's a little big. What makes this little 10 here 40? Well, we're going to have to multiply that by 4. But to not change the fraction, to keep it as a value of 1, we have to say 4 over 4. So this is going to be 4y over 40. All right, what about the 5 right here? We have to multiply that by 8, right? So 8 over 8. Which means we're going to get 8 times 2, which is 16 over 40. Plus, well, 8. We're working with 8 now. Well, to get 40 there, we need to multiply by 5. So that's going to give us 15 over 40. Okay. So now we know that 4y over 40 equals 16 plus 15 over 40. Well, 15 plus 15 is 30, and one more makes one of those 15 16, so that's going to be 31 over 40. So we have a common denominator of 40 on both sides, but if we just simply multiply by 40, it goes away here, and it goes away here, And we now know that 4y equals 31. So we're going to either divide by 4 or multiply by 1/4. Either one is good. And y equals 31 over 4. Now 31 is a prime number. It has no factors except itself and 1. So that's just the end answer there. All right. So that concludes today's explanation of how to do these problems. If you're seeing stuff like this and having trouble, you're not able to make a session, shoot me an email. Bring it up somewhere. Talk to me about it. I can only help you if you ask me to. So, thank you all, and I hope you have a great day.